I will now do examples of finding the inverse of a matrix by using the adjoint method. This was kind of derived before. Here is the formula for it. You need to know how to find the adjoint of a matrix, and then you divide it by its determinant, and that is the inverse if the determinant isn't zero. But actually, for 1 by 1 and 2 by 2, it's easier just to remember formulas. In fact, 1 by 1 is almost trivial. If you've got a single element matrix, say it's -3, the inverse is just the 1 by 1 matrix with the element -1/3. You can get it from this formula, but it's not worth doing. Anyway, for the 2 by 2, instead of following the normal formula for an adjoint, all you're doing is, remember, you swap the main diagonal terms, so the 4 will go upper left and the 1 will go lower right, and you change the signs of the off diagonal terms. So the 2 and 3 become -2 and -3. The determinant was easy enough. 4 minus 6, that's -2. So applying this formula, here's your inverse. If you multiply it out, there it is. This was good enough for my students to show me. Once you get up to 3 by 3, it gets kind of tedious. You've got to find the determinant of the whole 3 by 3 and all 9 cofactors. In this case, I expanded by that bottom row because it has a 0 in it. So this plus minus plus 1 times 2 minus 0. There's the 2. And a plus minus plus minus 4 times -4 minus 15. That arithmetic says the determinant is 78. It's not 0, so it does have an inverse. I'm not going to go through each one of these. The 1, 1 term, get rid of the first row and the first column. We're left with this little matrix here, 0 minus 2, 4, 0. Take that determinant, 0 minus a -8 is 8. So each term in this matrix has a corresponding cofactor. Put all those cofactors into a matrix and then transpose it. That's your adjoint. You got to transpose it. If you're good, I would write out this matrix when I did it and then transpose that. If you're good and you have all these numbers, you can say, well, this top row is going to be that first column. So anyway, the inverse is then this matrix divided by that 78. It's just kind of tedious. There's no magic to it. I'll save Cramer's rule for another